This question was asked from the GATE Physics paper 2021. This is a MCQ type 2 marks question, and this question was asked from the topic quantum mechanics. The question is, consider a state described by psi as a function of x and t equals to psi 2 plus psi 4, where psi 2 as a function of x and t and psi 4 are respectively the second and fourth normalized harmonic oscillator wave functions, and omega is the angular frequency of the harmonic oscillator. The wave function psi as a function of x and at time t is equal to 0 will be orthogonal to psi as a function of x and t at time t equal to four options are given. Option A is pi by 2 omega, option B pi by omega, option C pi by 4 omega, and the last option, option D, pi by 6 omega. So we have to choose the correct answer from these four options. Let us see how to solve this problem. It is given in the question that our wave function psi as a function of x and t is basically linear combination or superposition of two different state harmonic oscillator wave function. Those are psi 2 and psi 4. Here psi 2 is the second, that is the n equals to 2 state normalized harmonic oscillator wave function, and psi 4 is the fourth, that is at n equals to 4 state normalized harmonic oscillator wave function. Now for a one-dimensional harmonic oscillator problem, the energy of the nth eigenstate is given by En equals to n plus half h cut omega, where omega is the angular frequency of the harmonic oscillator and n defines the state of the harmonic oscillator. Here n can take the values 0 or any positive integer values. Now harmonic oscillator potential energy is time independent. So for this case the wave functions will be stationary state for the harmonic oscillator problem. This means at any time t, we can write the time evolution of any harmonic oscillator wave function, that is psi in as a function of x and t equals to multiplication of two independent functions, and first function is basically the wave function at t is equal to 0 times one exponential term, that is e to the power minus I e n t by h cut. So this exponential time dependent term basically describes the time evolution of the harmonic oscillator wave function. Here En is the energy of the harmonic oscillator state at nth state. So we'll apply the definition of the stationary state in our case. So our wave function psi as a function of x and t equals to psi 2 times e to the power minus I 2 t by h cut plus psi 4 e to the power minus I e4 t by h cut. Here psi 2 represents the wave function psi 2 at t is equal to 0, and psi 4 is the wave function at psi 4 at t is equal to 0. Now if the wave function psi at t is equal to 0 is orthogonal to the wave function psi at any time t, then we can write the inner product between these two wave functions is 0. Now at t is equal to 0, basically the wave function psi is psi 2 plus psi 4. So we'll write this psi as a function of x and t is equal to 0 is psi 2 plus psi 4, and psi as a function of x and t is given by this. So we'll write that here. Then we'll multiply this psi 2 with this 2 term and psi 4 with this 2 term, and we'll expand this. So we'll get 4 terms from here. So first term will be the inner product between the psi 2 and psi 2 multiplied with the exponential term, and second term will be inner product between psi 2 and psi 4 and this exponential term containing the energy term E4, and third term will be the inner product between psi 4 and psi 2, and the last term will be inner product between psi 4 and psi 4. and also multiplied with the energy, the time evolution part. Now the wave functions psi1, psi2, psi3 and so on, they represents the normalized wave function for the harmonic oscillator, and they are orthogonal to each other. This means the inner product between the same wave function will be 1, but inner product between the two different wave function will be 0. This means our inner product between psi2 will be 1 or psi4 will be 1, but the inner product between psi2 and psi4 or inner product between psi4 and psi2 will be 0. So because of this, if we remember the last equation, in that only two terms will survive, which contains the inner product between psi2 and psi2 and inner product between psi4 and psi4, and rest of the terms will be 0, and that will give e to the power minus I e2t by h cut plus e to the power minus I e4t by h cut equals to 0. Now we'll divide the whole part by e to the power minus I e4t by h cut. So basically it will give e to the power I e4 minus e2t by h cut plus 1. So we'll take that plus 1 at the right hand side. So it will give this equation. Now from the complex number theory, we know e to the power I pi is basically minus 1. So we'll write this minus 1 as e to the power I pi. Now comparing the exponent part, we can write basically e4 minus e2 times t by h cut equals to pi. From the last equation, we can write the time p equals to h cut pi divided by e4 minus e2, where E4 is the energy of the harmonic oscillator at n equals to 4 state and E2 is the energy at n equals to 2 state. Now we have already seen the energy of the harmonic oscillator at nth state is n plus half h cut omega. So we'll apply that formula and we can write E4 minus E2 as 4 plus half h cut omega minus 2 plus half h cut omega. So this will give E4 minus E2 equals to 2 h cut omega. So we'll put this in this equation. So we'll get T equals to h cut pi divided by 2 h cut omega. So h cut and h cut will be cut from the numerator and denominator, and we'll get our time T equals to pi by 2 omega. So this time at this time pi by 2 omega, basically the wave function psi at t is equal to 0 will be orthogonal to the wave function psi as a function of x and t. So this t equals to pi by 2 omega, that is the option A, is the correct answer for this question. So according to our solution, the wave function psi as a function of x and at time t is equal to 0 will be orthogonal to psi as a function of x and t at time t equal to option A, pi by 2 omega. So option A is the correct answer for this question.